Okay, now we're going to do, now that I have my pen charging, let's do test 2. So Vic Firth produces a certain type of drumstick that weighs 51 grams. They naturally vary by weight and tolerance, and the tolerance is 1.2 grams. That means the difference or the distance between the actual weight and 51 is always less than or equal to 1.2. That's how we write it in absolute value. So then we have to solve absolute value inequality, excuse me. We know that there are two different things that we have to have memorized. Either the absolute value of A is less than or equal to B. That means that A is jammed in between B and negative B. Or if absolute A is bigger than or equal to B, that means that either A is greater than or equal to B, or A is less than or equal to negative B. Because really what you're saying here is that the distance between A and 0 the distance between A and 0 is less than B. So here is 0, and here is negative B, here's positive B. So that means that A lives somewhere in here, right? Its distance, maybe A is right here. Its distance is somewhere in between negative B and B. And then over here, if you say that my size is greater than or equal to B, then that means that I either have to be out this way or I have to be out this way. I have to be more than B away from 0. So that means it's either out this way or it's out that way. So those are really the two absolute value types of problems that we talked about. So there's those. So if I can get it into this form, then I can change it into this. If I can get it into this form, I can change it into this. So here, when you see this, it's not in one of the two forms, so you subtract 24 from both sides and get this. Well then, it's not absolute value related to other numbers. This negative 2 is causing a problem, so I divide both sides by negative 2. That makes it 10 over here, but it also flips the inequality. So then now I have an absolute value is less than or equal to 10. So I have a thing, and its size is less than or equal to 10. That means my thing is jammed in between 10 and negative 10. And my thing was x plus 5. So now I have a 3-part, a compound inequality. We got 3 parts here. I just subtract 5 from each piece, and I get this. So that means that x has to be jammed in between negative 15 and 5, which is this. So I knew it had this form, so I was able to turn this into this. Okay. Now we see this one, and notice if I subtract 1 from both sides, I end up getting this guy, and using my discussion from earlier, I can change this into either this or this, two separate disjoint pieces. So when I solve the one on the left, I get x is less than 7.5. On the right, I get x is greater than or equal to 15. So that means I either get this or I get this. So that would be my answer. Notice we have these because you're allowed to be equal to, and we have this bracket because this is equal to. All right, here, now solving this one. So the other two are absolute value inequalities. This is an absolute value equality. We know that if the absolute value of A is equal to B, that means if my size, that's what absolute value is, my size is B, then on the number line, I'm either sitting exactly here or exactly here, either at B or at negative B. So A is either sitting right here or right here. So what I'm really saying is that either A is equal to negative B or A is equal to B. It's one of those two. So anytime you see this, you can replace it with this. So if I've got this, I simply add 3x minus 2, the absolute value of that, to both sides, and end up getting this. So what does that mean? If my size of my stuff is 7, then either my stuff is -7 or my stuff was 7. So I solve those and I get two possible values, either 5/3 or 19/3. Here, finding an inverse. This was on multiple quizzes. It's an important question. So how do I find the inverse for a function like this? I need to know that find an inverse, I switch and solve. I switch x and y. That's what it means to be an inverse, switching the role of x and y. And then I solve for y. And there you go. So switch here. And then once you have this fraction, it's important to know once you switch the roles of x and y, it's important to know that we multiply both sides by the denominator. These cancel out here, and we get this. But then I distribute through the x to get this. And now remember, I'm wanting to solve for y. So then I get everything involving y on this side, everything not involving y on this side. And then over here, I now factor out the common y out of both of these and pull it out here. And now I have y times something equals something else, so I just divide. It is absolutely okay to stop right here, or if you want to simplify a little bit, you can get that. Okay, so now I'm at 6. It says graph the inverse. Well, guess what? The inverse is a mirror image about the line y equals x. So if on f, if you have 0, 1, then on the inverse you have 1, 0. So I put a point here. If on f you have 3, 0, then on the inverse you have -3, 0. Then on the inverse you have down here 0, -3. So make sure that I labeled that is 0, -3, right? All right. So then they say, use the graph to evaluate, or use the graph to evaluate. So if I do f of an input of 0, I get an output of 1. Check. It says what x value gives you a y of 0? Well, I do this, and this is the x value that gives you a y of 0. So it's -3. Here, it says f inverse of some y. What is it? Well, I know if I undo a y, I get back an x. So really what they're just saying is f of what x gives you -1. So what do you have to plug in to get out -1? So I draw a -1, and it turns out that where does y equal -1 hit the graph? It hits it right here. So it turns out that if you plug in -6, you get -1. So if you undo -1, you get an input of -6. Well, here, if you undo something and get out -3, that's the same thing as saying f of -3 is equal to what? So f of -3 is equal to what? Your answer is 0. So notice how these and these are very related. Okay, then it says find the value of y that is a linear function that goes through the following points and has a slope. If I go through these points and have this slope, well, I needed to know that the equation for slope is y2 minus y1 over x2 minus x1. Must be memorized. So if the slope is 4/5, I can plug in this slope here. And then I just start giving them names. And I say, look, let's let this be my x1, y1. I'm going to let this be my x2, y2. It doesn't matter which ones you do, yeah? Okay. So when you do that, you end up getting that 4 is equal to y minus 1, or in other words, y must have been 5. And there you go. You can just solve for y. All right. Look at 12. It says, tell me if these are parallel, perpendicular, or neither. Justify your answer. You must justify, or you get no credit. Well, first, if we take, what did I do? Top one stays the top one. I end up taking the first equation and I solve it for y and I get this. Then I take the second equation and solve it for y and I get this. Well, notice that in the first equation, the slope is 5/3. In the second equation, the slope is -3/5. So since the product of the slopes is -1, that means they are perpendicular. That's one definition of what it means to be perpendicular, is that the product of their slopes is -1. You could have also said that they are negative reciprocals. Yeah. All right, 13. Is that about it? Yes, it's 13. So for 13, in 91, the moose population was 4,360. In 99, it was 5,880. Assume that the population grows linearly. As soon as they do that, I know that I'm working with this model, right? Okay. So if they want to know a formula where it's time since 1990, then 1990 is time equals 0. So that means this is telling me that at time 1, the output was this. That's my T, comma, M for my population. Ooh, it's at a population P. So I should have used P instead. Let me use P instead of M. So, excuse me, instead of moose, I'm going to say P for population. Boop. And I'm going to call this P. Is that better? Yeah? Just to go with the exact letter they used. Okay. So, so that means the information they gave me really turns out to be these 2 points. So there's 2 points that have to go through my line. Well, 2 points define a line, so we're going to be able to figure it out. Well, I write down, here's the equation of a line. Again, must have it memorized. And so to find this line, I can plug in an x1 and a y1. I end up using this. So now the only thing I have to solve for is m. So to find that slope, I must have my slope formula memorized, y2 minus y1 over x2 minus x1. And I go ahead and keep it straight and call this one x1, y1, this x2, y2. And when you plug in everything, you get that 190 is what m is. And so this is your equation of the line. And now I can use it, if I solve for y, now if I plug in any x value, I can find my y. Where x in this case is really t, right? X and t are the same thing. Sorry if that's confusing. So they wanted to know what happens in 2003. Well, that would be for an input value of 13. When you plug it in, you get 6,640 moose in 2003. Awesome. I'll be back with the last video.